Hi everyone, today we are going to discuss CAD tool change essentials and its approaches. Here we will discuss the things to consider while switching to a new CAD tool. Our agenda for today. It starts with introduction to CAD tool change. Then the CAD analysis, which is divided into source CAD study and trigger points. And then the CAD selection, which is divided into feature mapping, limitations, additional capabilities. And the CAD conversion, it consists of neutral file exchange, feature-based translator, and remastering. Lastly, summary to conclude. Let's talk about introduction. At times, when an organization expands or acquires or globalizes, it makes it evident to change their CAD toolsets to sustain and grow the business. However, switching CAD software is a big task. Organizations need to be aware of the risks and difficulties involved in doing so, as some of the features and details of design are lost in translation. Unless otherwise, the approach chosen is remastering. CAD tool change consists of three major factors. It begins with the analysis of features and functionalities that are used in the design and development of source data. Then come the factors to be considered during selection of a new CAD tool. Finally, the CAD conversion approach to choose from various available options in the market. Moving further to source CAD, where analysis plays an important role while switching CAD tool. CAD applications in general are versatile and vast, hence the probability of finding an organization which harness the full potential of a CAD application is close to none. So, understanding the elements that are essential for business continuity is important. CAD analysis involves study of all features and functionalities used by an organization in CAD software. Example: features used for modeling, integration with PLM or PDM systems, customized constraints and features, customized validation tools for assemblies, standard part library, data export options used for downstream business activities, and so on. Such analysis provides clear understanding of critical factors in CAD applications that are absolute necessity and the ones that hold least value. Moving on to source CAD study, which can be categorized into three parts. Firstly, the analysis of features used. In this case, team understands all commands or features used in organization across all domains. Secondly, the configuration. This is where all the organization-specific CAD configurations are analyzed in detail and recorded. Configurations such as drawing templates, material libraries, standard part libraries come under this category. Lastly, in customization, team analyzes the custom scripts or programs or commands deployed on source CAD system that are to be migrated to. Take for example, custom validation tool used for checking part and assemblies construct, tolerances, constraints, and so on. Coming to the next slide where we are going to see trigger points for CAD analysis. CAD software offers lots of functionality, but there are always few areas where CAD team face some or the other issues. Such pain points in most of the cases trigger the need for CAD tool change. Take for example, many companies do site consolidation to implement single CAD software as they can attract more discount as no of licenses increased. Also, in case of merger and acquisition, organizations preferred to have single CAD software to attract more discount. Other CAD-specific trigger points are: performance of application is low. Excessive time required to work on large assemblies. Saving the data back into PLM is a tedious task. Version control issues while revising and saving data back into PLM. Resolution issues. Upgrade issues. Customization issues. Non-availability of advanced features, and so on. Let's take a look at CAD selection. CAD selection starts with the comparison of technical details of source CAD system and the potential target CAD systems. Potential target CAD systems will have to pass through the preliminary requirements before they are considered for full-fledged comparison. CAD selection is a crucial task that involves the contribution from all the areas starting from design and development to manufacturing and servicing. Source CAD analysis is taken as a baseline to look for target CAD software capabilities. Needless to say, they should offer seamless and reliable integration with PLM or PDM system of the organization. Furthermore, we will see feature mapping, limitations, and additional capabilities in detail. Here we will get information about mapping of features and functionalities of source CAD into target CAD system. Mapping CAD features begin with thorough understanding of the new system's capabilities, limitations, software versions, and architecture. It helps to identify gaps and similarities between source CAD and target CAD application, create documentation for target CAD application. This is the schematic diagram of mapping features to consider a new CAD system. It will help different features to be mapped at different levels. Next point is limitation of new CAD system. Every software has some or the other limitations. It is essential to understand limitations of potential new software and their impact on broader scale. Such limitations should not affect the organization's short and long-term goals. Different CAD software are suitable for different engineering domain, as each one of them offer domain-specific advantages over other. It should be noted that if CAD tool changed, certain areas will be affected. For example, feasibility to recreate all the customizations present in source software. Furthermore, we will see about additional capabilities. The implementation team should also look for additional software features that will be useful to them in the future. It should fulfill the additional requirement that CAD teams are looking for, like easy integration with ECAD, CAM, digital manufacturing, quality software, and CAE tools. Also, options for customization are important so that in future, if there is need of customization, it can be developed and used. Take for example, some software are now offered with cloud services. If organizations don't need it while conversion, but might need it at later point in time, then this will be a point of consideration too. Coming to CAD conversion. It is the process of translating source CAD data into target format so that the files open in target CAD software successfully, while allowing usage of all the features and functionalities targeted in the conversion. There are several tools available in the market for CAD conversion, ranging from the standard export and import tools from the CAD application providers themselves to the ones that are developed by other vendors to fit the custom requirements. These tools come with pros and cons, so selection of approach completely depends on organizations' needs such as budget, time, target CAD application, and complexity of CAD data. Methods for CAD migration are as following. Neutral file exchange. In this case, the source data is converted into a lightweight format and then the same is loaded into target system. The next one is feature-based translator. In this case, the source data is converted into target CAD format directly using feature-based translator tools. The last one is remastering or CAD factory. This is the case where data is remastered by a team of designers manually. Here, in this slide, there are three approaches of CAD conversion. Firstly, in neutral file exchange approach, model is exported through SolidWorks using step file format and being loaded in NX. Only dump solid is available without features. Secondly, in feature-based translation approach, model is translated into NX using translation tool. Here most of the features gets converted into NX compared to neutral translation, but translation cannot overcome with remastering approach. Some features fail conversion, which are to be handled manually. Lastly, remastering approach, model is loaded in SolidWorks and being remastered in NX. All features are converted unless the target software doesn't support a particular one. Coming to the first approach of CAD conversion, which is through neutral file exchange method. In this approach, source CAD data is exported to staging location in neutral file format, which then is used to load data in target CAD software. Neutral file formats such as JT, STEP, CGR, and IGES are used. Take for example, converting source CAD to STEP is one of the approaches as it is an enriched format that supports NURBS modeling but misses out on the polygon modeling. At the same time, STEP 242 can hold PMI information. And converting source CAD data into JT is another approach, as it supports polygon and NURBS modeling, and contain PMI information. It doesn't contain material and texture information unlike the other neutral file exchange formats, but material application is better done using PLM and CAD automation scripts, where material in PLM application is applied to the CAD data. Below are the pros and cons of neutral file exchange in comparison to other approaches. Pros are: less implementation time as the end results are simple and easy to validate. Involve less cost. Faster migration process. And then the cons are: migrated data will not be feature-based. Designers will have a limited information in CAD to resume their work in target application. Drawing can be transferred through neutral file format like DXF, but associativity will not be available. This is a typical example of CAD conversion using neutral file exchange method. Source CAD files are converted into a neutral file formats using the translation services available in the market. Neutral files are then stored in the staging folder and loaded into target CAD system using loading utilities. Neutral file format has two categories: first is 2D file format and second one is 3D file format. In 2D neutral file format, drawings can be transferred through DXF format. In 3D neutral file format, models and assemblies can be transferred through IGES, JT, CGR, and STEP formats. Second approach of CAD conversion is by feature-based translator. This approach is achieved through translators developed by various companies. These translators create feature-based model inside target CAD software by taking reference of model available inside the source CAD system. This approach is recommended if the source data is of good quality and migration timeline takes priority over budget. There are many translator tools available in the market. Some of them are CMM, Theorem Solution, Transmagic. This approach too comes with pros and cons as other approaches. Talking about pros: basic feature-based model will be available inside target CAD software. Drawing associativity will be maintained. Feature tree will be available. Attribute can also be transferred. Migration time will be less than remastering. Assembly constraints can also be transferred. And talking about cons: higher cost involved usually in comparison to neutral file exchange. Complicated model may fail and will still need remodeling in target system. Approach becomes cumbersome for substandard source data quality. Talking about one such translation tool, CMM. It is a feature-based tool developed by Siemens. This tool is used to translate various non-NX CAD data into NX data. CMM also contains extensive reporting, validation, and options for configuring the results. CMM supports the migration of part features or part boundary representations, assembly structure or constraints, and associated drawings. Coming to remastering, this is a technique that is used to create proper feature-based model in different CAD software from model available in source CAD software. In this approach, a separate team is built or hired to convert existing CAD model into target CAD software formats. Team uses existing model and drawings as base and follows the standard design procedure to create models in target system. Remastering is basically one of the formats of reverse engineering. Sometimes neutral file formats are also used to extract and match exact geometry of original CAD parts. Remodeling is a time-consuming process, so it is outsourced in most of the cases. Many a times, transfer of the file from one format to neutral file format contains some of the errors, thus it may not be possible to use such files for further modifications in target CAD system. These errors are due to the open profile and overlapping surfacing in surface designs. Such issues will be resolved when remastering approach is chosen. Moving on to the next slide, we will see pros and cons for remastering CAD conversion. The pros are: feature-based model will be available in target CAD software. Drawing associativity will be maintained. Better integration with downstream applications and reduced engineering cycle time. Existing design data can be reused to create new designs. Quick design turnaround, increasing efficiency. Design team can immediately start development. And cons are: increased expenses. The migration process will take time. This slide talks about the process of remastering. It starts with loading the CAD files from source system, analyzing its features, structures, and attributes. Then remodeling them in the new system manually and save it into the target system. In summary, there are various options, approaches, tools, and strategies available for CAD conversion. The most followed approach is the combination of some or all the three approaches. Say for example, legacy data that is required only for reference purpose can be migrated using neutral file exchange approach. Simple data that is required with all the features can be migrated using feature-based translator approach. And lastly, the complicated data that is required with features can be remastered in target system. Such combination of approaches based on the business needs provide best possible results. Thus, investing sufficient time in analyzing the data and requirement is must to conclude on the viable and suitable approach. Involvement of experts during initial screening is critical to lay a strong foundation for successful migration. We provide services to these Siemens products and also developed our own SmartPort application to automate issue reporting and resolution. Please visit our teamcenter and NX helpline, which is free and open to all PLM community. Here, you will get instant expert assistant, guidance, and best practices for your organization. You can also email us at mentioned email ID. Thank you for watching this video.